everyone, welcome back to On the Spot STEM. Today we're doing 2020 AMC 12A number 24. And the AMC 12A and AMC 10A were just yesterday. And so I hope you all got the scores that you wanted. And if not, you always have the B to do better. So the problem reads, suppose that triangle ABC is an equilateral triangle of side length S with the property that there is a unique point P inside the triangle such that AP equals 1, BP equals 3, and CP equals 2. What is S? And before I start on this problem, I'd like to mention that this problem was actually very similar to an old Amy problem. I believe it was 2012 Amy 1, number 13 or something. And so if you've done that problem, then you probably knew how to do this on the test. So I'll just go over the solution now. So we have this triangle over here, and it's equilateral. And we put a point P inside, such that AP equals 1, BP equals 3, or root 3, and CP equals 2. And something that jumps out to us right away is that 1 squared plus root 3 squared is equal to 2 squared. And this isn't a coincidence, this is actually a very nice condition, but we want to somehow use this in the problem. And this is obviously Pythagorean theorem, so we maybe want to find a way to change this triangle such that we have a right triangle of side lengths 1, root 3, and 2. And so, basically, if 2 is a hypotenuse, then we'd have to have something like 1 and root 3 over here. Or we'd have to have something like root 3 and then 1. And they're both right angles. So, basically, since we have the 1 and root 3 over here, let's imagine what would happen if we rotated the triangle ABP. Let's rotate the triangle ABP 60 degrees counterclockwise. And so what that does is it transforms B to C, since if you're rotating 60 degrees counterclockwise, then since angle BAC is 60, B goes to C. P goes to this new point, we'll call this P prime. And then this is our new triangle. So this AP prime C has the same side length as APB, and it's just it rotated 60 degrees. And so, since it has the same side lengths, because rotation preserves distance, that means AP prime is equal to 1, and CP prime is equal to root 3. And so, now since we have a root 3, 1, 2 over here, let's see what happens if we join P prime. And if it's equal to 1, then that's very good for us, because then it's a right angle. And so, notice that angle BAP plus angle PAC is equal to 60 degrees. And since angle PAP prime is, since BAP got rotated 60 degrees counterclockwise, that means angle CAP prime is equal to angle BAP. So these two are equal. And that means angle PAP prime is equal to angle BAC. And so what that means is that angle PAP prime is equal to 60 degrees. And what that means is that PAP prime is equilateral, since PA is equal to AP prime, so it's isosceles with a base angle of 60 degrees. And since it's equilateral, that means P prime is equal to 1. So, that means PP prime C is a right angle. And what that means is that the angle AP prime C is equal to 90 plus the angle AP prime P. So, angle AP prime C is equal to angle P prime C plus angle A P prime P. And that's equal to 90 plus 60 is equal to 150. Since AP prime P is an equilateral triangle. So we rotated this triangle, and that means all the lengths were the same, so that means all the angles were the same too. So if AP prime C is equal to 150 degrees, that means APB is also equal to 150 degrees. So APB is equal to 150 degrees. And that means if this is a side length S, by law of cosines, S squared is equal to 1 squared plus root 3 whole squared minus 2 times 1 times root 3 times cosine 150. And simplifying, this gives us 4 minus 2 root 3 times negative root 3 over 2, which is equal to 4 plus 2 times 3 over 2 is equal to 7. So that means s squared is equal to 7, and s is equal to root 7. S is equal to root 7, we go back to our answer choices. We see that it's answer choice B, and we're done. Thank you for watching. If you enjoyed this video, please like and subscribe. We're going to be uploading the solutions to a lot of other AMC 12A and 10A problems in the coming few days. So be on the lookout for that if you want to see a problem done. And if you want to see a problem done specifically, then please comment it in this video or another video, and we'll try to get to it. Thank you.